Hello again, class. Today we're going to just continue on in section 5.5 with a few more trig equations to solve. For all of the equations that we're doing in this video, we're going to only solve them from 0 to 2 pi, so just once around the unit circle. So let's take a look at this problem number 5. 4 cosine squared of x minus 3 is equal to 0. Okay, so what I want to do first is I want to get cosine squared of x by itself, and then I'm going to take the square root of both sides to solve our equation. So step 1, we're going to go ahead and add 3 to both sides, which gives me 4 times cosine squared of x equals a 3. And then take the 4 and divide it on both sides. So divide by 4. And what we're left with here is cosine squared of x equals 3/4. I want to get this down to just cosine of x, and so what I'm going to do is take the square root of both sides. And remember, when you take the square root of both sides of an equation, your answer is going to be positive and negative. So let's see what we get. Take the square root of both sides, and what that's going to leave me is cosine of x. I have the square root of 3 over the square root of 4. Now the square root of 4 is 2. So what I have is the square root of 3 over 2, and remember we just took a square root, so it should be positive and negative. So let's see if we can find our reference angle. What angle has a cosine of root 3 over 2? Well, look at our angle, and that's going to be pi over 6. So our reference angle is going to be pi over 6. And if we think about the quadrants, if I want positive and negative, I'm actually going to put this reference angle into every quadrant. So I'm going to put it, here's quadrant 1, and in quadrant 2 I would have 5 pi over 6, and in quadrant 3 7 pi over 6, and in quadrant 4 I would have 11 pi over 6, and that will give me all of the solutions, both positive and negative, in each quadrant. And there we are. Here's our next problem, number 6. Sine squared of x plus 5 sine of x is equal to 0. I notice here that I have sine of x in both of these terms. So since this is already set to 0, I'm going to go ahead and factor out sine of x from each term. That will give me sine of x. Well, sine of x into sine squared of x will leave me a sine of x plus sine of x divided into 5 sine of x gives me just a 5. And I factored out the greatest common factor, sine of x. Set each factor equal to 0. My first factor is sine of x. So I have sine of x equals 0. My second factor is sine x plus 5. Set that one equal to 0 as well. And solve. So let's take a look at our first equation. Sine of x is 0. So where is the sine of 0? Let's see. Let's look at our unit circle. Looks like it's at 0, right? And also over here at pi, the sine is also 0. So I'm going to say for this one, x equals 0 and also pi. Now I'm not going to say 2 pi because remember we're solving on the interval from 0 to 2 pi, but we don't want to repeat ourselves. When they have a little parentheses on that 2 pi, it means that you can't really include 2 pi. So we're going from 0 all the way up to 2 pi, and so only 0 and pi would be the answers for that one. Now my second equation, let's solve this for sine x. So I'm going to subtract 5, which gives me sine of x equals negative 5. Is there any angle that has a sine of negative 5? No. Again, negative 5 is too small because, again, sine of x or cosine of x can only be from negative 1 to positive 1. Negative 5 is definitely too small. That one's going to give me no solution for that part. So the two solutions for this equation are just 0 and pi. We have one more problem to try. Here it is, number 7. Tangent x sine squared x is equal to 3 tangent x. In this one, I notice that tangent x is in both of these terms. Don't divide it out. It's a little tempting to do that because you say, oh, let me divide both sides by tangent of x. But you're throwing some answers away if you do that. What we have to do is set this to 0 first, then we're going to factor it. So I'll have 3 tangent x. I'm just going to subtract it from both sides. That's going to leave me tangent of x sine squared of x minus 3 tangent x equals 0. And now I can factor tangent x out of both terms because it's in both, here and here. Factor tangent x out, and that will leave us just sine squared of x minus 3. And still set to 0. Let's set each factor equal to 0. My first factor is tangent x. Set it to 0. My other factor is sine squared of x minus 3. And we'll set that one to 0 as well. So for our first equation, where is the tangent 0? Let's look at our unit circle. Remember, tangent is y over x. So where's the tangent 0? Well, at 0, we have 0 over 1. That would work. Tangent is also 0 at pi, because I would have 0 over negative 1. The tangent's undefined at pi over 2, and it's also undefined at 3 pi over 2. So only at 0 and at pi. So x equals 0 and x equals pi. Let's solve the rest of this one. So when I solve for sine of x, what I'm going to do is add 3 first to get sine squared of x equals 3. And then I'll take the square root of both sides, positive and negative, to get sine of x equals positive and negative the square root of 3. If you take the square root of 3 and put that in your calculator, you're going to see that the square root of 3 is definitely bigger than 1 again. So square root of 3, it's too big. Negative square root of 3 would be too small because it can only be between negative and positive 1. So this is not going to yield a solution. One more time, that's just not going to give us an answer. But the only solutions we get are x equals 0 and x equals pi.